Welcome friends. So today's topic is time and work from quantitative aptitude. So this topic is very useful. This fundamentals is very useful for final year students because nowadays every company used to take entrance exam. In that technical paper is there, at the same time aptitude paper is also there. Okay, so all types of entrance exam are there in which aptitude will be there. Okay, and not only technical entrance exams like bank PO, I.B.P.S, railway recruitment board, S.S.C. So all types of MAT exam, CAT exam, all type of entrance exam, in that general aptitude is there, and this is the most asked chapter, means questions are there generally from this chapter, time and work. So today we will see this chapter, time and work. Okay, so let's start. So in this chapter, time and work, it is very simple. See, I will show you this. Today we will discuss these three fundamental things, and some we will solve some examples. So I will tell you some 10 to 11 examples. If you understand those 10 to 11 examples, you can solve any problem from time and work. Okay, so we will see one by one. Okay, so before we go for problems, we have to understand these three fundamental things. Very simple. Okay, so we will see. So see, the first one is, if A can do a piece of work in n days, then A's 1 day work is equals to 1 by n. Okay, so what it is saying, if A can do a piece of work in n days, then A's 1 day work is 1 by n. Suppose a student can read 9 chapters. Okay, total 9 chapters are there. So a student can read 9 chapters in, total work is 9. Okay, 9 chapters are there, and a student can read those 9 chapters in say 3 days. 3 days. So student can do a piece of work, that is 9 chapters in 3 days. So then student's 1 day work is 1 by n. 1 by n. So here 1 by n is what? Ours 1 by n is 1 by 3, because he is reading that 9 chapters in 3 days. Okay, days is 3. So you have to remember that work and time are inversely proportional. Okay, so if he is doing some work in n days, then 1 day work is 1 by n. So if he is reading 9 chapters in say 3 days, so in 1 day he is reading 1 by 3. Okay, so that is I think you have understood this one. Now the second one is exactly opposite to that. Okay, if A's 1 day work is 1 by n, suppose a student is working or reading, say work is 1 by 3. Okay, then A can finish the work in n days. Okay, A can finish the work in n days. These fundamentals will be very much clear when we solve the simple examples. Okay, so say first example, what I have told you, total 9 chapters are there to read, and a student can read 3 chapters. A student can read all 9 chapters in 3 days. So if A's 1 day work is 1 by n, say our one student can read 1 by 3 work in 1 day, 1 by 3 work, then A can finish the work in n days. Then that student can finish that work in 3 days. 1 by 3 means 3 days he can finish, because total 9 chapters are there. So in 1 day if he is doing 1 by 3, so in 3 days it can complete, because 3 into 3 into 3, in 3 days he can complete the 9 chapters. And the last one is based on the efficiency. Okay, so if A is thrice as good as B, if student A is thrice as good as B, then ratio of work done by A and B is 3:1. Ratio of work done by A and B is 3:1. A's work is 3 and B's work is 1. Why? Because A is thrice as good as B. And time is reversed. This is work, ratio of work done. Now time and work are inversely proportional. So ratio of times taken by A and B to finish a work is 1:3. So A can finish that work in say 1 day, B can finish that work in 3 days. Okay, why? Because A is thrice good as B. Suppose A is twice good as B. Then what will happen? 2:1 and 1:2. As simple as that. So these three simple formula or say understanding you should have if and you have to remember that work and time are inversely proportional to each other. Okay, so if you have understood these three simple things, we will solve problems. We will solve total 11 problems, 10 to 11 problems. If you are understanding those 10 to 11 problems, I am sure that you will be able to solve any problems on time and work. Okay, so we will start solving examples. Okay, so this is the first example. Okay, we will solve this example. See what it is telling. Motu takes 8 hours to do a job. Motu takes 8 hours to do a job. Patlu takes 10 hours to do the same job. Okay, generally Patlu take less time, but our Patlu is lazy, so Motu finishes faster. Okay, so Motu takes 8 hours to do a job. Patlu takes 10 hours to do the same job. How long should it take working together? So if both are working together, how long should it take? Okay, so first of all you have to read the question at least for 2 times. You should see how many persons are there. Generally 2 persons will be there generally, but it can be 3 also. Okay, so 2 or 3 persons will be there and we have to work on that. So be a Gabbar Singh and ask kitne aadmi the. Generally 2 sardar. Okay. So we will see. Okay, so Motu takes 8 hours to do a job. Now our first formula, what was that? A is taking 8 hours to do a job. That means 1 day work is 1/8. So we will write like that with the same. Okay, so Motu's, so I'll write in short. Okay, Motu's 1 day work. Motu's 1 day work, according to our first formula, Motu's 1 day work is 1/8. I told you time and work are inversely proportional to each other. 8 hours is the time, so 1 day work is 1/8. Okay, Motu's 1 day work is 1/8. Then Patlu's. Patlu's 1 day work, how long it is taking? He is taking 10 hours. So Patlu's 1 day work is equals to 1/10. Work and time are inversely proportional to each other. How long should it take working together? If both are working together, here they are working independently. If they are working together, how long it should take? Okay, so A plus B simply. So Motu's, so we will solve here. Motu's plus Patlu's, bracket over, Motu's plus Patlu's 1 day work is equals to, Motu's is 1/8, Patlu's is 1/10. Take LCM. (18 divided by 80), that is 9 divided by 40. Okay, so if both are working together, 1 day work is equals to 9 by 40. 1 day work is 9 by 40. We want time. How long should it take? We want time. So time is inversely proportional to work. So 1 day work is equals to this. So time is what? Inversely proportional. So they will take, the answer is time inversely proportional to work. So the answer is 9 by 40. So 40 by 9. So this is the answer. 40 by 9 what? Hours. Or the answer can be like this also. 9 into 4, 36 and 4 hours. So if both are working together, if Motu is working alone 8 hours, if Patlu is working alone to do the same job, he is taking 10 hours. If both are working together, they can complete the work in 4 hours and 4 by 9 hours. So this is our answer, and this both are correct. Okay, different way of writing. So this is our answer, 4 and 4 by 9 hours or 40 by 9 hours. Okay, so this is the simplest one, first problem. Okay, now we will move on to second problem. So this is the second problem. Okay, let me read out. Laila and Majnu together can complete a work in 4 days. Okay, they have taken 4 days to complete a work. If Laila alone can complete the work in 12 days, Laila alone is working and she can complete the work in 12 days. I don't know how. In how many days can Majnu alone complete the work? If Majnu alone is working, how long should he take to complete the work? Okay, so according to our first and second formula, third formula is for efficiency. Okay, thrice good, twice good, for that only. Otherwise first two formulas will be useful, and with those first two formula only you have to solve all the problems. So we will take the first formula. Laila and Majnu together can complete a work in 4 days. Now in last problem they have asked that if both are working together, Motu and Patlu, how long should it take? Now here they have given the answer. Laila and Majnu are working together and they can complete the work in specific 4 days. And if Laila alone is working, then 12 days. So if Majnu alone is working, then how long should it take? Okay, so we will go by that formula only. So by the first formula, Laila and Majnu together can complete a work in 4 days. So Laila plus Majnu's together, Majnu's 1 day work is equals to, this is the time, so inversely proportional is the work, so 1 by 4. So Laila and Majnu's 1 day work is 1 by 4. Now we will read forward. If Laila alone can complete the work in 12 days, so Laila's 1 day work, 12 days means 1 by 12, because time and work are inversely proportional to each other. So Laila's 1 day work is 1 by 12. Now what they are asking, if Majnu alone can complete, Majnu alone is working, how long Majnu will take, how long time Majnu will take to complete the work? So simple, the same formula as first one, A plus B. Okay, so we will solve like this. Laila plus Majnu's 1 day work is equals to Laila's 1 day work plus Majnu's 1 day work. Okay, Here we know this one and we know this one, and we have to find this one. Simple. So how to do? Laila plus Majnu's one day work we have found out, or we have means we are having 1 by 4. So Laila plus Majnu's one day work is 1 by 4 is equals to Laila's one day work. Laila's one day work is 1 by 12 plus Majnu's one day work. That we have to find out. Just what we have to do? 1 by 4 minus 1 by 12, that is equals to Majnu's one day work. So what it will be? 12 minus 4 divided by 12 by 4. Okay, so 8, 12 by 4, 2 and 6, 1 by 6. So Majnu's one day work is 1 by 6. Work is 1 by 6. We want time. So time and work are inversely proportional to each other. So 1 by 6 inverse is 6. So how long Majnu will take to complete the same work? 1 by 6 means 6 days. That is the answer. Okay, simple one. So we'll go for the third problem. So this is the third problem. Okay, let me read out. Santa is twice as good as Banta. Now this is the third type of problem in which our third fundamental, what I have written, 3 fundamental things you should know. So in that third was there, that is the use. Okay, means that will be used in this one, efficiency type. So Santa is twice as good as Banta, and together they finish a piece of work in 18 days. Together, if they are working together, Santa and Banta, they can finish a piece of work in 18 days. In how many days will Santa alone finish the work? So if Santa alone finishes the work, how many days it will take? Okay, so we have only one input, that is they are finishing a piece of work in 18 days, but we are having second input also, that Santa is twice efficient as Banta. So means Santa is say reading one chapter, Santa is reading 2 chapters in one day, Banta is reading only 1. Okay, so work is more for Santa and time is less. Okay, so we will solve. So what we are having? First of all, our same formula. First we will write what is given. Santa is twice as good as Banta, means the work ratio is given. So Santa's one day work divided by Banta's one day work is equals to twice good. Santa is twice good as Banta. So he is good, so 2 and 1. If you are taking time taken, then it will be 1 by 2. So Santa is taking less time compared to Banta. Now in case of work, it is 2 by 1. Okay, so this is given by 2 because it is given twice. If it is given thrice good, then we would have taken 3 by 1. Okay. Now second input, together they finish a piece of work in 18 days. Together they finish a piece of work in 18 days. So second input, Santa plus Banta's one day work. One day work is 1 by 18. Time, so 1 by time, that is work. So Santa's plus Banta's one day work is 1 by 18. Now what equation we are having? We are having equation Santa's, or say Santa plus Banta's 1 day work is equals to Santa's 1 day work plus Banta's 1 day work. We are having this equation. Okay, previously also in Laila Majnu, or say who was that first one, Motu Patlu, we have used same equations. So working together is equals to working individual, simple maths. So Santa plus Banta's 1 day work is equals to Santa's 1 day work plus Banta's 1 day work. Okay. So we will solve. So this is there. Now Santa's plus Banta's 1 day work is given 1/18. Now we will put the values. So 1/18 is equals to Santa's 1 day work. We know that one? We don't know. Santa's 1 day work we don't know. We have only this input and this input. So this we don't know. We will write as it is. Okay. Santa's, or what we can do here, instead of writing as it is, what we can do, see Santa's 1 day work, here Santa's 1 day work is there, so it is nothing but if this is going this side, then Santa's 1 day work is equals to 2 into Banta's 1 day work. Okay, so I will write this one, Santa's 1 day work is equals to 2 into Banta's 1 day work. So I will write here 2 into bracket Banta's 1 day work. Okay, so Santa's 1 day work we have written from here plus Banta's 1 day work plus Banta's 1 day work. Suppose x, so 2x plus x, that is 3x. So that is nothing but 3 Banta's 1 day work, 1/18 is there. So 3 will go this side. So what we will get? Banta's 1 day work, 3 is going this side. So 18 into 3, 54, 1/54. So we got Banta's 1 day work is equals to 1/54. What is the question? In how many days will Santa alone finish the work? We don't want Banta's answer. We want how long it should take for Santa's. So we will put this value in this equation so that we will get Santa's answer. Okay. So I will remove this one. So Banta's 1 day work is equals to 1/54. So from here we will get Santa's 1 day work is equals to 2/1 into this one, Banta's 1 day work is equals to, this will go this side. So 1/54, 27. So Santa's 1 day work is equals to 1/27. This is work. We want time. So time is inversely proportional to work. So Santa will take 27 days to complete the work alone. So this is the answer. Santa will take 20 days. If he is working alone, he will take 27 days to complete the work. Okay, so 3 types of problems we have seen, and first we have started with the fundamentals. Only 3 fundamentals you have to understand. How to write means, just one thing you should know, that time and work are inversely proportional to each other. Okay, depending upon that we have written 3 fundamental formulas. Based on those 3 fundamental formulas we have solved 3 problems. Okay, now in next video we will solve more 3-4 problems. I think within 2 or 3 videos we will complete total 11 problems, 10 to 11 problems. If you understand these 10 to 11 problems clearly, I guarantee you that you can solve any problem on time and work. Okay, so happy learning. If you have any doubt, you can write in the comment box, and you can mail me also. I told you my email ID before also. I'll write here again. Chirag V MISTRY at gmail.com. chiragvmistry@gmail.com. Okay, so if any doubt is there, you can do a comment. I will reply. Or if you have suggestions for any topic like this time and work, what are the topics in which you are finding difficulty, I will solve, and I will try to tell you about all these aptitude questions in which you are having problems. Okay, so in next video again we will solve more 3-4 problems. So I hope that in 3 videos we can complete this time and work chapter. Okay, so that's it for today's. Okay, thank you.